Alright, so let's look at a different problem. And here I'm borrowing this one from the homework. It says for each of the following pairs of formulas, prove or disprove that they are equivalent. So we'll just look at the first pair. Here we have E, F, P, and E, G, Q. This is the first one, they are a pair. And the second one is E, F, B, and E, G, Q. The first thing I like to do is to try to make sense of what these mean and what do you think we're asking you here. If you just compare them by looking at them, we're asking you if we can add brackets here. Does this change anything? That's a question. Are they still equivalent or not? What does it say here? It says that there exists a path where eventually B is true and at the same time parallel to the starting point. This is the same starting point. There exists a path, could be the same path, could be a different path, where forever starting that point, global Q will be true. Whereas this one, I'm saying there exists a path where eventually this whole thing will be true. So in the same state B is true, this will be true. Well, I'm not asking you to solve it by looking at it. I'm just trying to make sense of the problem myself. That's how I would approach it. Very careful though. There are many ways. This is a statement. This is like a logical expression, a specification of a problem. You can interpret this in many ways. And I want to be so clear about this because that's a very common mistake. I'm asking you here to prove or disprove these two pairs. This is the first one. This is the second one. Or this pair, sorry. Now, you can't just draw some diagrams and tell me they are equivalent or they are not equivalent. You need to show me why. Because why that is. It's not to give you a hard time, but if I tell you FP, for example, and FB, that's a statement. Eventually B will be true. And that's a statement. Eventually B will be true. Different students, different models, different systems could behave differently. Here's the first one, for example, and here's the second one. Here you could tell me that B is true in the first one, we're done, problem solved. Here you can tell me B is true here, or all of them even, it can be. I didn't say anything about requiring them, but it can be. As long as one eventually is true, this is good. Those two models satisfy those. So by drawing a model, you can't just draw it such that they are equivalent and then tell me they are the same. You see what I'm saying? If I go here and I say this is S0 and I say XB, so next one should be B, right? And then I tell you to also draw GB. So you're gonna say B, 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 great. But are these equivalent? These are not equivalent, obviously. They're not equivalent. But if you put B, B here, this still satisfies this. The only specification I required was that if we're here, and this is true here, that this will be B. This is all I required. But if you add B's here, sure, why not? So those look the same, but they are not equivalent. So you're not just gonna draw a diagram and say, based on this diagram, they are equivalent or not equivalent. You see what I'm saying? You need to make the proof more substantial. Okay. Let's go back to the question itself. Okay, so I'm not saying don't draw it, you need to draw it, but don't base the analysis just based on the way you draw it. So we're gonna draw this one, for example. I try to save some time by using something that I have previously drawn. Okay, so that's a structure, for example, and I'm gonna look at the second one here. So exists, eventually we're gonna have P, and exists global Q. What does this mean here? It means that if I am in S0, there will exist a path, one of those two I have here. So that's what the E means, where eventually in one of those paths we will have P and E, G, Q. So one of them is enough, so I'm just gonna ignore this one, for example, and we're gonna go with the top one. What do we know about this node? Well, not much. I know that eventually B and E, G, Q will happen. This is not true here necessarily. If this is true here, then this is not true here at the same time. You know what I mean? So I really don't want to label, let me highlight this. I don't want to label this state with this statement. Don't take the F in account here. F here just means eventually in this path that we've decided on. You can decide on the other one if you want. But eventually, somewhere in those paths, somewhere here, this will be true. That's all I'm saying. Okay. So let's just say it will happen here, that I will have P and E, G, Q. So this will be B, and then exists a global Q, maybe here. This will be Q as well. This has to be Q as well, right? Because this path will branch. It can be here or here, but it has to branch from here. So it will be global Q in one of these. But if I have like other ones here, but branching from here, this will be always Q. So that's an interpretation of this. Okay. One way to think about it is now we can go and take A. Can we try to fit A in here or 1 in here or not? Can we manipulate it such that this one can fit here or not? Let's take a look at it. I'm gonna use blue here. We're starting from here again. E, F, P, and E, G, Q. I don't want to answer this question because it's a homework question, but I'm just showing you how to think about it. So we are in this branch. Both these are true in the sets or the initial set. So let's just look at them one at a time. E, F, P. There exists somewhere either this one or this one. There exists means one of them will have an eventually be somewhere. I can decide to go this here, by the way, and I can go, it can be here. I have P. It's true. Okay, that's one of the cases. And we go back to the initial state because this and was at the initial state. And E, G, Q. There exists a global Q. So Q would be true here. If I take this path, then Q, 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 and so on, we'll have P and Q here. Or you can also take the different path, and it will be, and that's the part that's kinda tricky. If you take the different path, then I will have Q, 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 and so on. So if you take this path, you will never have P and Q. Like you had here, B and Q. You will never have B and Q because you will not be inside this set. You will just be going up in the upper branch. So, doesn't need saying, these are never gonna be equivalent. And you need to you can explain why. I will accept an explanation of why this is the case, but it's better to also try to prove what happened. You can write something like, for this system or branch that I model here, the initial state, if the initial state I have exists eventually B and exists global Q, then if I start with this, if this is true, then it will never be such that S0 will not be equal to E, F, P, and E, G, Q. So just to recap here what's happening. You start with one of them. Here I started with this one. I drew a model, a world, an interpretation where this one is true. This is good. Can this one fit in the interpretation of the first one? Somehow, can we manipulate it such that this E takes the path that is the same as this, but it can it be different? Will they fall together all the time in all the interpretation? Obviously they will not, as we saw here. So we're kind of formalizing the expressions, but it's clear that we cannot just rely on the drawing. I know it sounds contradictory. We cannot rely on the drawing, but you need to draw the drawing. Yep, you need to draw the drawing, but you need to be more thoughtful of this. Just like I was saying, F could be true if I say F B is, and B can be true in any of these, right? You have to be cautious. You have to be paying attention of the fact that those could be equivalent, different interpretations. So again, you're drawing an interpretation, a branching system, specifying the model, but you're also comparing to the second one, and you're aware of, you keep them flexible. Like, you think of all the different ways in which you can model this and all the different ways in which you could model this. Are they always going to be the same or not?